We are going to continue our session with two wonderful speakers. The first being Mr. Marco Arredondo. He is a 1980 electrical engineer graduate of Texas A&M University in Kingsville. He has over 30 years of experience in electric utility rates, energy and design, most recently overseeing the implementation of proper rates, design of systems and lighting, heating and cooling, waste and heat recovery, demand and energy management, control and thermal energy storage. He is now president of Marco A. Arredondo Incorporated, providing services to customers in the areas of utility rate negotiations, demand site management, and the evaluation of equipment to optimize production and energy consumption. Please help me welcome Mr. Marco Arredondo.
Thank you.
Along with Mr. Arredondo is Mr. Eddie Campriano Jr., who was born and raised here in the Rio Grande Valley. He is a graduate of University of Texas at Arlington. He is currently the Energy Efficiency and Conservation Coordinator for the Brownsville Public Utilities Board. He has been an active member of Rio Grande Valley Sustainability Council for the past 2 years. Please welcome Mr. Eddie Campriano.
Ari, I tell you, I'm Marco Arredondo. I don't know if I laid one of these on every chair, in front of everybody. Does anybody not have a copy of what I'm going to be handing out? All right, so if everybody's got one, I guess we're good to go, because everybody talks about energy savings and what kind of equipment do I put in and how does it, I see a bunch of good numbers out there, but it usually just takes one day out of the year. And I'm an ex-CPL engineer. I used to work for CPL. I'm a good guy now. I don't work for the utility company. But really, all we were trying to do, even back then, was make a customer more energy efficient. And to try to get an idea of who I'm addressing is who's school district or education here in the room. Okay, who's industrial or commercial? Okay, who's consultants or somewhere in the industry? A lot of people not raising their hands. All right.
For the bad guys, I'm one of the bad guys.
He's still with PUB. No. Eddie, you want to tell them a little bit about yourself, what you do?
Absolutely. As Marianella said, I'm with the Brownsville Public Utilities Board. I handle all the energy efficiency and conservation aspect to it. I more deal with the residential side of it, but everything we're talking about today can certainly be equated to that residential side, even though we're more addressing the commercial and industrial side. So all these worlds can be interchangeable, so you can take these home with you as well. But what we're going to touch on first, and Marco's really going to quarterback this, is fantastic, is understanding the bill, the breakdown of it. Great, everybody pays that monthly bill and has that same, the electric company's getting me again. Well, it's easy to, it's really beneficial to understand what's really going on. And so that's what we're going to start off doing today.
What I did here is we're now in the deregulated process unless you're with Magic Valley or you're in PUB. And what I did here on the first page of this handout, it says Marco Arredondo Inc., is where we typically start. If you look up at the top left-hand corner, I just kind of, I have several customers, and I said, okay, let me just take an average. And so this customer uses 65 million kilowatt hours a year, all right? And right underneath there, it says estimated TDSP, and that's what you see on the half of the bill that you never really quite know what's going on. Those are the transmission distribution service provider charges. That's what AP charges you for the transformers, the facilities, the power lines, actually how do you utilize the energy. In this case, in this customer, that charge is 3.8 cents per kilowatt hour. So about $3 million a year of their $7 million budget, or about 40% of their bill, doesn't have anything to do with the energy contract. So when you start addressing, and we were talking about all the chillers and the technology, how do we really drive that $3 million down? You'll have a lot of people say, well, I'm going to save you a lot of money with energy contract. Well, here, energy contracts now, and this will show you typical bids right now, even going out to 4 years, you get energy contract about 5 cents per kilowatt hour. So you're going to save $3 or $4 million per year because of the energy contract, but that's because rates are low. What happens after 5 years from now and rates go back up to 8 cents or 9 cents per kilowatt hour? You're going to be right back in the same boat where you were. So as we save this money, the biggest charge that I have as a consultant for a lot of my clients is to allow administration to allow us to keep some of that money that we saved and put it into the chillers or the new high efficiency equipment. So when those rates come back up, we've cut the $3 million part of the budget down. What do I typically see? Anywhere from 2 cents, and I've seen some as high as 5.5 cents. And when I see them that high, there's stuff that can be done. You know, you've got to know what you're doing. And I wanted, if you flip to the next page, a Constellation new energy bill. All right, I put this in here because there are utility retail providers out there that I call sophisticated, and there are some that just give you a one-line item. Our company audits all our customers' bills on a monthly basis. We look at all these fine charges. We find hundreds of thousands of dollars in errors because somebody just plugged in the wrong number, or a computer didn't see the right thing. But this is the energy part of the bill, that first page. If you look up at the top, you'll see energy charge. This customer's at 6 cents per kilowatt hour right now. The contract will be expiring this year, and they'll go down to 4 cents. So they're looking at a lot of savings coming here in the near future. But you'll see a lot of base charge and all these EILS, the nodal charges. In 2011, ERCOT went from a 6-zone system in the state of Texas and said everybody in the South Zone pays the average rate. You all share in the cost. In the North, they pay their own rate. Now they've got over 4,000 points, and everybody will pay their fair share. So if you're out of control and you're not managing your energy right, you're going to pay for it personally, you know, in your company, organization, or school district. They are, now that it's more sophisticated, in February 2011, when we had that hard freeze, you saw some of your guys' bills went up by 2 cents per kilowatt hour for that 1 month. Some went up by 3 cents. That was the actual cost to get the energy to you, because we had one of our coal-fired plants, not one of mine, I don't work for CPL, but a coal-fired plant in the state of Texas, go down, so they had to get energy from somewhere else. You now have to pay for that energy for that day or for that month. And I can tell you, a lot of my customers, before I could buy the insurance or the risk margin in the energy contract, they would just pass it through without a markup, and it turned out to be 2 or 3 cents. So if you're using 100,000 kilowatt hours a month, your bill went up by $20,000 that month. I mean, it was a huge hickey, nothing you can do about it. Going forward in the contracts, we can cover it for a nominal fee in the energy contract. Now, flip to the next page, and this is what I want to address today. This is what really is, and you won't see it with a lot of bills. They give you one line item and say TDSP charges, and that's it. Now, on the Constellation New Energy bill, you'll see that up there at the top where it says meter read, I want to address power factor. The third line over, it says power factor. This customer has a power factor of 77%. That's significant, because to this customer, that 77% power factor, if we can correct it to 95%, will save that customer $100,000 a year on the demand charges, which is what I'm going to be covering today. And you go, wow, that's a lot of money. And yes, it is, and that's forever. Once you correct it, these fees are what I call forever charges. And this is where you really want to play. And I want to drive it home. We can talk about rebates and everything, but this is what helps us reduce the power plant. So if they're at 77% power factor, that means that they could be 23% more efficient. So if you're putting 1,000, let's just say, because you all buy emergency generators, if you've got a 1 kW emergency generator, you can only address 770 watts. So the other 230 watts on that generator are being wasted through heat or some other line loss. And that's why AP and everybody wants you to be corrected to 95%. They want their power plants to be as energy efficient as possible. They don't want to waste 23% through heat in a motor, all right? You correct those through variable frequency drives, through capacitor banks, but there's ways to correct that energy. With this customer here, an installation probably about $7,000 will save them $100,000 a year. Just got to know what you're doing, where you're doing it, how you're doing it. So the payback is almost immediate. So it's a no-brainer. Of course, even though it's a no-brainer from the engineers, it's not always a no-brainer from administration. They still say, well, we'll work on it. So it's our job as consultants to say, okay, we're $200,000 later. When are you going to spend $7,000? Because they just kind of put you on the back burner, but you've got to work on it. On this sheet down here on the bottom, you'll see a lot of components. You'll see a distribution charge. It's $27.47, and now you see a $29.45 the units and an $8,000 charge. anything that doesn't have a kilowatt hour next to it is a component that you're getting directly charged for demand. For a school that's tax exempt, about $9 per kW is what you pay for demand, or tax exempt. If you're not, you add taxes to that at 8%, it's about $10 per kW demand, all right, which is a significant part of the bill. Because say if you use 1 kW demand, if you divide that by 10 cents per kilowatt hour, you could have used 100 kilowatt hours before you spent the money for 1 kW demand. And the easy way to put it to you is, I've got two 1,000 watt lights, two 1 kW lights, and I don't need both of them on, but if I turn both of them on at the same time and leave them on for 15 minutes, that meter from AEP, all it takes 15 minutes anytime, 24 hours a day, and you hit that 2, you're going to pay $10 per month, and for that month, more than you needed to, and 80% of that for the next 11 months. There is an 11-month penalty of 80% of that little hickey. And I've seen some customers that have two 500-ton chillers. Say it's 1 kW per ton, so it's a 500 times 10, it's $5,000 because you turned it on for 15 minutes. Even if you turned it off, minimum charge, $5,000. So what would he do? He said, well, I don't want my building, I don't want anybody to be uncool, so he loads up the other 500-ton at the same time before he turns off the other one. That was a $60,000 a year mistake. All right. You know, anybody in here knows you can ride a building for an hour without any air conditioning. So what you do is you get one off completely offline, and then you bring the other one up and you ramp it up slowly to keep your demand at a minimum. It's kind of like with a car. You don't want to floor it. You want to just get there. You want to get there in time, but you want to get there as easily as possible. And so demand is what you really, really want to address with everything that you do. And I will now move to the next page. I'm going to show you an elementary. These are real numbers. This is what happens out there. This is what we do as forensic engineers in my company. Every month when we look at every bill, at every account from every city, county, or school district, or industrial customer, this is what you get from AEP. And I don't know, maybe you guys have requested your history from AEP. Maybe you have an online account where you can look at it. But what's important here, and I bolded it where it says metered KW, it's the fourth column over. And in February, which was the bad month for this last year, you notice they've been having a demand of 319, 377, and all of a sudden there's the demand of 558 kW. Because in February we had that freeze, and all your electric strip heat came on because everybody wants to be warm. All right, so all of a sudden now, if you go over to the billed KW, which is a couple of columns over, all of a sudden their billed KW goes up to 558, but what I want to be important there is that 80% of that for the next, well, we haven't gotten to the next year, but the minimum bill now is 446 kW for the next 11 months. And if you look at the metered kW, they have some months with 274 kW demand, but they're paying double. And I put a real simple little thing down there at the bottom. The difference is 1,066 kW between the billed and the metered. And so the hickey for that one day is almost $10,000 a year that you didn't have to pay. All right? But you're not watching, you know, and everybody wants to be warm. Everybody's warm, everybody's happy. What he was alluding to, and I see and the more efficient you make your air conditioners, the worse your electric heat becomes. Because now you've got a bigger disparity with what you're actually doing and saving. So what we've always harped on all the way back, I was a CPL for the first 15 years, is heat pumps. In South Texas, we should use heat pumps. And you know, those of you that are familiar with heat pump technology, it's just like an air conditioner. You're moving the heat out of the building in the summer, and in the winter now you want to move the heat back into the building, so you're cooling the outside. You want to use that same 14 or 20 EER compressor to heat your building, you know, as opposed to using, the way I like to put it is, if you turn on electric heat strip, you got one unit of energy for 1 unit of heat. And the EER on an air conditioner or the SEER is, how much better can I get with that? You know, you get 14 ERs, I'm getting 14 to 1. So when you reverse that cycle with a heat pump, all of a sudden now, anytime you're 1 degree below your heating point, what happens at a school? You turn on your electric strip heats. You're playing with fire. Or even any building. All right, so what you want to do is you want to use that compressor energy. And the last time I did the research, and we're almost back there at $2.50 MCF per gas, the break-even point between the COP of a heat pump and gas heating was 3 to 1, and it happens when it's 18 degrees outside. So is a heat pump cheaper to use? All the way down to 18 degrees, that's the break-even point. And with the newer technology, it's probably below that. But you know, when you get down that low, how often does it happen? There's no sense in me spending more time doing research on why should I do it, how much. When it was 450 an MCF, I mean, even worse. You shouldn't even think. And so what I want to do with you guys today is, and with some of my schools, we're trying to wipe out the word air conditioner off of vocabulary. We want to go in with heat pump technology. I like the idea that you just heard where you recycle your dehumidified air, because one of the biggest concerns, and we addressed it already, was, well, in the winter, if I'm heating with a heat pump, how am I dehumidifying the air? Because you're not cooling it, you're not reheating, you know. But really, the lower, you got drier air in the winter, so it's rarely going to become an issue. But if it is, you could reverse the cycle through your controls, turn on a little bit of the heat strips to reheat it, and still keep your demand down. 5-ton air conditioner, 20 kW electric strip heat, all right, typical. The compressor energy at 1.5 kW per ton is 7.5 kW. So when you're using the air conditioner, you got to pay the 7.5 kW, but you don't have to pay the 20. When you use your heat pump, you probably will use only 10 kW heat strip, because you're using your compressor energy, and then you might supplement with heat strip. And so you're only going to lose a little disparity between 7.5 and 10. And it's a heck of a lot better than 7.5 and 20. All right, when you're talking about that $10 per kW. And so that's why when you see all these incentives that Eddie's going to talk about and I'm going to talk about, when Clear Results says, I want to give you $150 per kW to get off the grid, it's because, you know, when you have a 600 megawatt plant, you actually, you want to make it more efficient. The other thing that people aren't paying attention to is, and that's why we talk about project design and retrofit. If you've got a school or a high school, and I've seen this so many times, you know, that high school operates during the day. And then you build a stadium right next to it, you put another meter. But if you were to connect that high school meter and you serve that stadium out of it, if you just really pay attention to your design, a stadium typically puts 200 to 400 kW of demand with all the lights. It's getting better now. And so what's that 200 or 400 kW times 10? Minimum charge, $4,000. You use it 3 or 4 months out of the year, and then what about the other 8 months? You get 80% of that hickey, and you can save by combining those meters. You're doing sometimes $50,000 a year because you put your auditorium or your stadium on the same meter as your high school. Because what the utility company is looking at you through the meter is my customer operating 24 hours a day? They actually want you to operate 80 or 90% of that. Once you turn on that light, they want it. Out of those 8,760 hours a year, they like 80% usage, because when they turn on that power plant and they got that generator running, you're not using the energy at night. Somebody got to pay that energy, because I tell you what, we say, okay, well, you know what, you can't use energy at night. Well, you know, if you go to some of the third world countries, that's what happens. They all go down at night. But when you turn on that switch, I think every one of you wants the light to come on. And so that's what we've got to pay for. But that's what we talk about. There's some common sense things going out there. And when they say, well, what do you do? Well, Google Earth. I go out there, drive out campuses. Security's always asking me, what are you doing? Who are you? Well, I work for a district, and I'm out there. I'm actually tracing the power lines, finding the meters, identifying. And see, I've seen 5 portables sitting next to each other with each individual meters. So it doesn't matter when each one hits that 20 kW demand. It's what he was talking about. 5 times 20 is 100. 100 times 10 is 1,000. But if you put them all on the same meter and you have some diversity on that meter, you're probably going to save 10 to 20% of that demand. And then if you go with heat pumps, even better. But I've seen a lot of BARD units, and they're just, yeah, they're cheap, you know, but you don't look at those long-term costs of what happens there. The power factor on this elementary good news is, if you have DX air conditioning, power factor out here is about 99%, the last thing on the spreadsheet that I handed you out. When you go in with chillers or any kind of motors, there is a lag on the motor following the little magnets. You know, for us electrical engineering geeks, you know, you're always, when you're chasing that north and south pole, that's what creates that lag, and that wasted energy You feel it when you put your hand on its heat, and people say, well, you put a variable frequency drive, you touch the motor, it extends the life of the motor. So we are now saying, okay, so what do? We don't want to pay for demand because you don't want to create energy. You want to move energy. All right. Some of you have DX air systems, and you have them right next to the cafeteria, and you're heating water. So now you're talking about heat exchangers, a heat recovery unit, simple little heat exchanger with a little circulating water pump, about 50 watts, to circulate that water. You take that hot gas on the DX of your air conditioner, you run it through the heat exchanger, and you can, with a 5-ton air conditioner, it's possible for you to create about 500 gallons of 140-degree water per day. So you preheat and if you stay under 200 gallons, some of you know all the codes, then you don't have to go through all your mechanical codes because you're really just keeping water hot and you're preheating your boiler. There's heat recovery chillers, and if you want to get into that, Perry is the guy to talk to. I did them when I was with AEP. I put a couple of them in a couple of colleges up north, and they can replace 5 million BTU gas boilers. And you're just moving the wasted heat from your cooling tower, where you're evaporating all that water, and you'll take it and you'll preheat the water, just reversing a chiller. And so those technologies are available out there, and that'll keep your demand down. It replaces a lot of stuff out there. But so when he talked about it, and that's what I was going to tell you, okay, we go with a water-cooled chiller first, air-cooled chiller second. When you start getting to your smaller systems, if you're not going to put an air-cooled chiller, then you should start going to heat pumps. You really should get rid of that demand, because if you see here, every elementary out there, $10,000 a year, unless you really know what you're doing. And if you knew it was going to cost you that much, you might not heat up the school that much that day. You might say, you know what, today I'm going to leave it a little cooler because I'm going to pay for it for the rest of the year. $10,000 equates to 100,000 kilowatt hours. That's 1 month of energy for that elementary. So what does that do? It drops your bill down by 12%, 1/12. They're getting a free month just because you're watching and you're paying attention. But unless you're paying attention, you don't even know what's happening. And that's really what I wanted to drive home today, is what people aren't really looking at. And your bill, sadly to say, if you don't have a sophisticated bill, you'll only see the bill demand. You're not going to see the meter and the bill. So if you're not going back in the back office of it, or getting the history from AEP and doing forensic engineering on each account, you're not going to see it. Now, AEP has an online system where you register and you can get online and look at your last 36-month history and see what's going on. But with some of my cities and schools, you got to have the right phone number, the right access code, and it's a nightmare to set up and it's a bureaucratic stuff to say, can I change all the phone numbers to the same? You got to get them to change all the phone numbers the same so you can get on that online access. It takes a while, but it's very important to do it, because then you can get online on the AEP system and you can actually label your own meter and put your own directions on there. And it helps AEP when there's an outage, because you say, my meter is behind the portable on this street or that alley. You can put a physical location for your meter. And that's where we're headed with our clients. We actually want to GPS every single meter for our counties, cities, and schools, so that when we can, and then we want to tie it in, link it, say, okay, well, how much is that school? And we know where it's at and we know what we're doing. But unless you're really doing that kind of management, you save money broad strokes. You save the real money when you really, really look at what you're doing. Demand response, people talk about that. Schools, David Miller at Marine Military Academy, he knows that his cadets leave at a certain hour, and so he's playing the demand response. But you've got to know what you're doing, because you know what? You don't want to turn off the air conditioning in one of your schools and all your kids at the wrong time. But if you're really on top of your game, and you have some of these companies, there's Rodero out there, there's Sea Power, there's Enternaut, and they all pay percentages. They'll pay you up to $65,000 a year per megawatt. That's what's available to you. And AEP also has about another $30,000. So if you play the game, you can maybe get $90,000, or at least there's $90,000 to share with your demand response provider. But what they're doing is they're trying to avoid those grid failures. That's what that's all about. But I have very few customers on it, because I make them I know the ramifications of shutting down a crushing motor or a process line where things are going to freeze up as an engineer, and usually I scare them a lot. I say, okay, but it could happen at this day, so do you want to sign? But some people say,
Everybody pretty familiar with demand response when we talk about that? I mean, I know it may be a general term that people aren't exactly familiar with, and I don't know if you want to explain really what those companies like Internoc and things like that, what they provide.
what they do is they put a computer on your energy management system or on your piece of equipment. They get a 10-minute notice that you've got to take, and let's just for a 1,000 horsepower motor. You've got 10 minutes to get it offline. All right, so the grid is seeing 1,000 kW out there on the grid. They're having grid constraints because either there's not enough transmission lines. The Valley's still a good candidate for that. We don't have enough transmission lines when things really get tough. And so what they do is they want you to flip that switch, and they pay you a lot of money to get off. And some I've got some hospitals with 3,000 kW in emergency generator, and they go, we don't want to play. You got 3,000, you know, and they say, well, we don't want to play. And I said, okay, when the power goes out, you're going to play whether you like it or not. So if you've got the generation and you've got the capability, you might as well get the money for it, you know, because you may never use it. They did call, you know, for it in February of 2011. So we have had like 3 response calls. But that's what they want. They will give you money to be the first one to volunteer to go dark.
And the key is to be really, be on top of your game. Everything that we were talking about is just be on top of your game, really focusing on it, because for you guys, that's where it is. It's demand. And I can't drive home enough. You know, for us, we're looking at it, that's your spike. Okay, we have to have enough generation to meet that spike again, and then some. So again, looking back at that build KW demand, where that 1 month in February, it pretty much killed the rest of these demands for the next 11 months. So it's really key. If you can foresee what's going to happen, you know, accommodate yourselves so you're not having to do this. Because like I said, from our perspective, we have to have enough generation to meet that demand regardless. And going back into the demand response, again, if you're on it, it's certainly worthwhile. With us being a municipality, we're kind of impartial to them. And what I mean by that is if ERCOT calls us and say, hey, you got a load shed, well, we're not looking on the list of who's got the demand response contract with Edinburg. We're going to shut you off. So if you're off for 30 minutes or whatever small amount of time it is, and you happen to be next on our list on our feeder, I'm sorry, you're going to get it. But it just really makes sure that you're aware of all your options.
Yeah, and then that build KW, if you look above the 558 kW infraction, the year before the ratchet was 468. So they actually used more, they had a higher demand the year before. So actually what you're looking here at this $10,000 deal is less than what the infraction was the year before. But those are the kind of things we're talking about, and you know, heat recovery is obviously, at the home, you know how they're going to these tankless water heaters, right? Instant, save, don't waste energy. Well, I've had a heat recovery unit in my house supplying 240-gallon electric water heaters since 1989, and I haven't had to turn on my electric water heaters, all right? And so I'm circulating that water through my, it's a two-stage heat pump. And so, of course, you got to design the flow system between both water heaters to make sure you get the water right. But if I go to tankless water heater, now I might have 36 kW and heat strips installed because I got to heat that water when it's coming through one time. So I'm not wasting heat because it's not sitting there in a tank. Now, in a residential, until they start hitting us for the demand, it's okay to go with a tankless water heater. In a commercial design, it's a recipe for disaster because you're going to go gas, you know, sorry. But, you know, I used to be like CPL, and the word gas was blasphemy for me, but before I put in a tankless water heater in a commercial design, I will go gas. Yeah. It might go boom, but at least I'm not paying a lot of money. I got insurance for the boom. No. Yeah, you know, there are things that you do, and yeah, it's hard to get off that old Central Power and Light hat, but really the bottom line is what is the best thing that you can do. So as we talk about this, and I was listening to them, you know what, that extra insulation on that building, because what we're trying to do down here in South Texas is not have that. And it happened in the freeze of '83, you know, so I always remember the freezes because that's when all my power lines went down. You know, those are the days I didn't sleep. I was the operations engineer. I was in charge of keeping the grid on. And so I'm there, you know, like, okay, what do I do next? And like he says, sometimes you just go, there you go, fixed it, you know. But, well, because you don't want to lose everybody, you know, but you got to pick who you're going to have to take down. And so when you look at those things, now you go, okay, I do want to insulate more because we found out in those freezes that the state of Texas actually became a winter peaking state. Our biggest peaks were always where they put that 4 CP, where they charge you so much for your summer peak demand for the rest of the year on the transmission grid. There's been a couple of times where we've actually had more usage. And in February, in those, when you think we're not going to have a winter, all of a sudden you got that one day. And we actually use more generation than we did in the summer. And so, yes, we probably want to insulate because you want to attack the heating side now. That's where a lot of your savings are going to come from. And I know I've talked to a medico and he's not sure about heat pumps yet, but got to buy the right unit too. Well, you don't know the controls. I mean, at one of our school districts, we actually finally sold at one of our high schools, we went from DX rooftop units to a chiller system. And as we talk about, it's expensive and everybody says we're not going to do it. And we did it in the first year, we dropped our cost by 39% total to that high school, all right? And there's always tweaking to be done. The first month we had the heating on with the air conditioning. It happens. So we, instead of using 600,000 kilowatts, we used over a million. I didn't see it till after I got the bill, so I'm 45 days into disaster, and then we go, fix it, and they're still playing with the controls. But this year now, in the first 4 months, the year after, we saved 30% the first year, and we're 20% below that year to date in the first 4 months. So hopefully we will have saved 50% of the energy of that school. So any time that you guys have to fight the battle of going, as he was speaking, if we can go chill water, air-cooled chillers, we've got to do it. Because in the long run, it's going to save you a lot of money. If you're not in that game, then definitely put in heat pumps, take care of your controls. Anything else you want to add? I mean, it's
kind of reiterating, we could just tell you that we, that freeze, it was very substantial in February. In fact, that was our peak ever. We peaked at 302 megawatts. I mean, we've had some hot summers. I mean, believe it or not, but that February, he's absolutely right. That freeze absolutely killed it, and then you're going to see it on your bills. And again, driving home, it's the demand.
So the incentives are there to try and help you save money, but saving money is just sometimes a little bit of putting in the right equipment and using it correctly. But if you don't know how your bill is derived, and that's why I felt that my time best spent today was showing you how your electric bill works, and the ramifications of one day. In 2011, what was that freeze? Just 2 days. Remember, we had one real hard freeze one day. 2 days, it's $10,000 hit just for 2 days. And it happens here all the time. We've kind of gotten it away from it from this year. I thought it was going to hit, hasn't really hit, not that bad. But questions, I mean, I know I've given you guys a lot of information and I wanted to keep this kind of dynamic because I don't know if we're, go ahead.
Is that 15 minutes, is that a snapshot or is that a 15-minute duration?
24 hours a day during that meter read period. We don't care when you use it. When you use it, we got you. My old CPL hat. Yes, 24 hours a day for that meter read period. And then it resets every month. All right, but it is 24 hours a day. And the IDR meters are they record every minute now. What I found out in the old IDR meters, because the Texas A&M Corpus Christi was one of my accounts, when we went to one of them for the first time from the old mechanical meters, it was better. Lightning hit it, we had to estimate a bill because there was no mechanical backup to know how much that school had used in energy when it fried all the electronics. That's what I kind of see is going to happen in the industry. We got all these smart meters that are really smart till they get fried. I'm waiting to see. That's where, when I keep track of my customers since 2001, I have all the history on the building, what the uses were, at what periods of time. So when my customers have that kind of incident, I'll recreate a bill and I'll negotiate with AEP and say, this is a fair bill for this month. So if you know what you're doing and you're keeping track of the history, because we're talking about Senate Bill 7, House Bill 3693. So with our school districts and cities and counties, we are keeping track of the energy savings every year where we're trying to get that 5% reduction per year. And we're keeping account for, okay, you got a new school, so we're keeping track of the square footages. Our square footages are real square footages for air conditioning. If it's a warehouse or something, we try not to count that. If it's a little pavilion when they're playing basketball, you do have lights on there, but it's really, I don't think that was the spirit of Senate Bill 7. You know, Senate Bill 7 is really trying to get you to control your air conditioning demand and your envelope where your students are at in conditioned space. At least that's the way I interpret it, and that's the way I play that game. If there's industrial customers here, if you're running a process, I've seen some processes where they're running 300 horsepower motors in this line, they're running 300 horsepower in this line. So again, that's 300 plus 300, you know, which is 600 times 10 is $6,000. And they only run this line for 2 hours. And I go, you know, you guys, you need to just wait till you finish running this line, now run the other line, and you only pay 300, the 200 never shows up on the meter. So there are simple ways to save on your energy bill, no matter who you are, just by controlling your process just a little bit. Even like in a school, if you have your controls and you're in a hard freeze and you have electric strip heating, okay, just like you have a rolling blackout, you know, just stage your heating to roll around so you maybe only heat half the school at that time and then heat the other half, and you'll stay away from that demand. But until you know what you're doing and you know what you're paying, there's really no incentive to do it. You know, and that's what I was hoping to create today was a knowledge of the way to really save money. Yeah, I enjoy Hugo over here, mechanical engineer, electrical engineer. We dance, we bounce off ideas and say, can you do that? And I say, why not? But any other questions for me or Eddie? Yes, sir.
These notices we're getting where the meters are going to be switched to a computerized type,
The smart meters.
smart meter, is that going to benefit?
That's an oxymoron, you know. They say I'm smart meters. I don't know if they're really smart yet. They give you all these brochures, and I've gotten online, because that's my job, that's what I do. You know, geeks are us. So I get on there to see if I can actually find out where my energy is being used in the house and what period of time, because it's supposed to do all that. You know, it's eventually, the best part about the smart meter is when it does go down, it automatically sends a signal to AEP so they know you're out of power. They know they're losing money. So they're going to try and get you back online as soon as possible. Used to, you have to call in. I still tell a lot of my customers to call in, but some of my customers have 100 or 200 employees working at night. The power goes out. I have to get with AEP or Encore or TXU Centerpoint, find out how long I think the outage is, because we got 100 employees standing around waiting for power to come on, and we got to make a decision: are we going to send them home, or are we going to keep them online? You know, and some have heat baths where things are going to go bad, and we shut down processes. But it's like I tell you, when you're really taking care of stuff, you're not only looking at energy, but you're looking at personnel, and you got to look at, okay, how long am I going to be out, and what is my purpose? When do I send people home? And I know a lot of you are in those positions. They usually call you and say, I want my power back. No, air conditioning, right? Most of you in here, I want my air conditioning back on, because that's what most of us serve is customers like students, and you got to have that AC on. I hope it was knowledgeable. We got some time left for questions. Everybody's real quiet. Who's going to put in a heat pump? Put it in at home. Trust me. You know, it always starts at home. It never amazes me that I have some school districts where I talk to all the guys that are in charge, and they all have heat pumps at home, but they won't put them in at school. Because it's my money they're spending. No. What was it, 35 billion tax dollars? Yeah, and that's what Schneider and everybody's trying to do. They're all trying to make you more efficient. What we're trying to do is show you where your real bill is coming from. If you go back and you figure out what your TDSP charge and you're at 1 to 1.5 cents, you're doing really good in most cases. If you're at 3 to 4 cents, you need to call somebody. You know. Yes, ma'am.
I'm with the city of Brownsville, and we were awarded a grant in 2009 to retrofit our city plaza, and with lighting and HVAC controls. And so we did that. We did that with less money than we thought. So we were able to use additional funding to put in a new water, the same thing, controls and lighting, retrofits, upgrades in City Hall. Well, now that came in at a cheaper price. So now we have more money, and we're going to phase 3, in which we're going to put a new water cooler.
Okay.
So with that, do you recommend the pumps as well, the heat pumps?
Depends on the size.
It depends on what you're doing, and
I think it's a chiller, I believe.
Yes.
Correct?
Yeah.
So, you want to go back with maybe a high technology, high efficiency chiller.
what
Those premium ones?
Yeah, like the magnetic or something.
What you may want to do there, and I know I handle Cameron County as well, and I caught it at the tail end because communication is not always the the best, but they were replacing a boiler in the jail, and we could have done a lot of heat recovery there to preheat the water, and we're still going to do it, but I didn't want to, when it's already being awarded, it's kind of hard for me to go, stop, let's start again. I mean, they were having a water heating issue, and it needed to be taken care of for other reasons. But those are things that when you're at the right place at the right time, if you know what you're trying to do, you can save an awful lot of money just by moving energy.
Especially like a hotel or a hospital where you've got a
Constant. And I know David Garza, the Assistant City Manager of City Fargo, one of my clients, and they went through the same program. And as we look at the next step of saving for the city, and I started talking about heat pumps, he goes, well, Marco, why didn't you tell me that a year ago? Well, because when the grants hit, they hit, and everybody was in a hurry to get that money spent. They had to get their deals in there. And that's not a time to be learning about and that's why I like the school here. We're being very proactive, all right? You can plan for the future, and then you can take care of what you need to take care of. You can be prepared for it. You can have all your return on investment analysis done, and Snyder does a real good job of that. Sometimes they don't like me because I look at it and go, well, I don't, I represent the customer, all right? Even though I work with Snyder, I'm one of their consultants, and we work together quite a bit. As a professional engineer, my job is to represent the client, and I look at the best technologies and I say, is it really a good deal or is it not a good deal? Is it the best bang for our buck? And that's all we're trying to do, because there are good things and then there are better things. And what we're trying to do now is that's why this whole thing is beyond the first year. What are the better things you can be doing on there? One of them is understanding. Any other questions? All right. Thank you.